Hello! In this tutorial I'll be showing you how to make realistic trees in Unity using something known as L-systems, which is a way of generating self-repeating patterns that are similar to fractals. Okay, so the way we're going to generate a tree in Unity using L-systems is we're going to move a game object around the scene and spawn lines wherever it goes. So to start off with, we're going to create an empty game object, and let's call it tree spawner. Now this is going to need some code to move it around and spawn the lines. So we'll create a new script, and let's just call this L system script. Now for the lines we're going to spawn, let's create another empty game object, and we'll just call this branch. And let's give it a line renderer component. This just draws a line to the screen which always faces the camera. Let's just reset that and we'll tidy this up a little bit. We'll make this into a prefab because we're going to need to spawn a bunch of those later on. Now let's open up our script in Visual Studio and we'll get started with the code. Right, let's make this a little bigger. We'll get rid of the update function because we're not going to need that. When moving our tree spawner around the scene, we're going to be changing both its position and rotation, so it would help if we had an easier way of storing both these values. So let's just create a little class here. We'll call it transform info. And in this class we're just going to be storing the position as a vector 3, just call it position, and the rotation as a quaternion, just call that rotation. So let's create a stack here, so private stack of type transform info, and we'll just call that transform stack. The L system works by taking a string and performing some operation based on each character in the string. To get the pattern to be self-similar, we're going to need to repeat the sequence within itself, and a really handy way of doing this is with a dictionary of rules. So let's just create a dictionary here. It's going to take type character as the key and give a string as the value, and we'll just call this rules. Now in our start function, let's just define these values. So transform stack, it's just empty for now, so just put new stack of type transform info, and rules, new dictionary, character, string, and we'll add some values here. So yeah, let's put x becomes bracket f x close bracket bracket minus fx close bracket bracket plus fx close bracket. I'll explain what all of those mean later, you don't have to worry about it for now. And I'll make another rule for f, which is just ff. Okay, so now let's create a function. We'll just call it generate, and this is going to contain all the information that we need essentially to spawn the tree. So in our start function we're just going to call generate, and we'll now define what this does. Let's go back up here and we'll define a private constant string. We'll call this axiom, and we'll let it be equal to x. Now this is the starting point for our tree, so the tree will always begin with this one simple rule, and then it will expand based on that rule and get more and more complicated. So let's also define a string. So we'll call this current string, and we'll just set it to be empty, and we'll be using this in a sec. Okay, back down in our generate function, let's start off by setting the current string to be equal to the axiom. So it will start off just being x, and we're going to be using string builders. We need to be using system.text, I think. String, yeah, there you go. We're going to be using string builders because this makes it much easier. So we'll just create a new string builder. Just call it SB. Simple enough. And now we're going to loop through all of the values in our current string. And what we're going to do is sb.append, so this is just going to append just adds the value onto the string builder. So what we're going to want to do is if the character we're reading corresponds to a key in the dictionary, then we want to add the value from that key. However, if it doesn't, then we just want to add the character itself. So we'll make a ternary statement here. If rules contains the key, then we'll add the value corresponding with that key. Otherwise, we'll just add the value itself. Okay, and now we'll set our value for the current string equal to sp to string. So from here we have our new set of instructions. So what we're going to want to do is let's loop through all of those again, all the new values. And we're going to want to do something different depending on what the character is. So whether it's an F or an X or a bracket, we're going to want to do something different. So we'll just make a switch sentence here, and then we'll have different case for each of our characters. So case F. I'll just copy and paste this, make it a bit quicker. We'll have one for X. We've got plus, minus, left bracket, and right bracket. And then we'll have a default one as well. And for that we're just gonna send a message. For this we're going to need to use system. So using system, I'll go back down here, throw new invalid operation exception, and this is just going to send a message to the console. So we'll just say invalid outtree operation. Okay, so let's define what all of these do. Now, F is just going to draw a straight line. X, we don't want X to do anything, because all X is used for is generating more Fs. Plus is going to rotate our tree spawner clockwise. Minus is going to rotate it anti-clockwise. The left square bracket is going to save our current transform info, and right square bracket is going to return to our previously saved transform info. So for F, we're going to start off by storing an initial position. Let's call that initial position, and that's equal to the position of our tree spawner. And then we're going to move our tree spawner, so we'll translate that up. And for this, we're probably going to want to multiply this by some value for length, so we can define how long our lines are, because at the moment they're just going to be squares essentially. So up here we'll just we want it to be visible in the editor, so serialize field, private, float, I've just got length, and we'll give that a default value of 10. And so then we can multiply this vector up by our length value. And then this is where the branch we created earlier comes in handy, because we're going to need a reference to that now. So let's create another value up here. Serialize field, private game object, and yeah, we'll just call this branch. Now we're going to instantiate this branch. So game object, let's just call it tree segment, and that's going to be equal to, well, that's going to be the branch instantiated. And now we're going to set the line renderer values. So tree segment, get component, line renderer, set position, so at 0, which is start position, we'll set that to our value called initial position, and then 1, which is the final position, we'll set that to be the current position of our tree spawner. So transform position. And that's it for F. And for X, yeah, we don't want it to do anything, so we'll just leave that as it is. Plus, we're rotating clockwise, so we'll do transform dot rotate vector 3 dot back, and we're going to want to multiply this by some sort of user-defined angle value. So we'll go up here, we'll create another one of these, private float angle, and we'll just set the default to be 30. So we'll multiply this by angle, and then that's it. And then we'll do the same for minus, but instead of back, we'll do forward. So now for the left square bracket, this is going to be saving our transform info. So that's what we're going to do. We're going to get the transform stack, and we're going to push onto it our new transform info. So this will be equal to, well, the position will be the tree spawner's position, so transform.position. The rotation will be, oh, that's meant to be a comma. The rotation will be the transform's rotation. and then the right square bracket, which is when we go back to our previously saved values. What we're going to do is create a new transform, a new variable of type transform info, just call it ti, and that's going to be equal to the last thing on our stack, so transform stack.pop, which is going to generate that value, and then we'll just set our position equal to the position of ti, and we'll set our rotation equal to ti.rotation. So now let's jump into the editor. Yeah. Okay, we need this branch prefer, so I'll just put that there. Hit play, and yeah, you can see there we've spawned the first iteration of the tree. It's just 3 simple lines for now, and it's pink because it has no material, so let's just quickly add a material. I'll just call this branch. We'll make it brown. Yeah, that's kind of brown. Just give that a material. And we'll update the prefab. Okay, so we hit play again. Then yeah, you can see we've got the beginning of this brown tree. But we want to be able to see it with more iterations. So if you go back to the code, up to the beginning of generate, we're just going to want to loop through this string builder append statement here. So actually let's define how many iterations we want. So serialize field private int, just call it iterations, set that equal to 4, and then here we're just gonna do a simple loop through here. So put in I equals 0, I is less than iterations, and we'll just and then we'll move this into this loop, and we're going to reset the string builder every time. So string builder equals new string builder, and now we'll go into the editor, and you can see it's working. It's generating the first 4 iterations of this tree. But this tree doesn't look very realistic. So if we go back into the code, we look at our rules, this is why. So we've just gone with something very simple here. It generates this pattern, but it doesn't look much like a real tree. So if I just change this to bracket f minus bracket bracket x close bracket plus x close bracket plus f bracket plus f x close bracket minus x close bracket, for example, and then we run the script again, we get this, and this looks a lot more like a real tree. That's all for this tutorial, but the link for the final project is in the description, so feel free to play around with that and see what you can do. Thanks.